I've been standing for a while. Can't stop staring at those ocean eyes. Da 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 da. Can't stop staring at those ocean eyes. Your ocean eyes. Oh my god. Wait, can I hear myself soon? Hey, we're on the way to fly. Right now, so my whole head is clouded. Let's see whether. What are you doing? Okay, so this looks not like water, to be honest. What's this button that I was pressing back then? Well, let me switch to English keyboard. I think it was Windows space. But he doesn't do it. Behold, what manner of love the Father has given unto us. Behold, what manner of love the Father has given unto us, that we should be called the sons of God, that we should be called the sons of God. Behold, what manner of love. Because the noise texture is repeating, that's why it looks this terrible. Oh, sorry for you. Da, da, da. Okay, so disable repeat. What's doing my keyboard now? Oh, I'm pressing function key to pressing. Ah, what is doing my keyboard? What's wrong with my alt key? Che coulé. Come on, this is how spoiled the system, man. Today I'm not just sick. Ah, I don't think I'm learning this way. Do I return back to the book of shaders? I think we'll do that. I need to drink some water. The bottle. Oh. What's my network? Who's playing Despacito in full speaker at this time of the night? Like, no guessings.
Running your shader. As part of the construction of this book in my art practice, I made an ecosystem of tools to create, display, share, and curate shaders. These tools work consistently across Linux, Mac OS, Windows, and Raspberry Pi in browsers without the need of changing your code. Running your shaders on the browser. Display.
So what I'm going to try and do is that I'm going to try and type regardless of whether I understand it or not. I'll just type out the whole code. Then at every point I will edit my code to be what their code is. Hopefully the more I type, the more that we have in my head. So the shader look content. This elephant is too dominant. So. Is it not pop? I always have to read it myself. It's too like. Alright, so the uniforms that I'm supposed to, let me just get my resolution uniform. Uniform, like, so, wait, something was looking weird just now. This is my resolution. Is it supposed to be? I'm also get uniform, vec, Siri, mouse. Oh, this is a different look. Why does it look like this? I never knew that she could dance like this. She can't come out, I wanna speak Spanish. Although I'm not going to be using this DRU timer because Godot has this time uniform. I mean, it's time and variable function. Just in the editor image. So let's save this scene. Let's call it book of shader. Hopefully, maybe using a book. Just as the way I was able to hold the things I read from Godot documentation on the shader syntax. maybe I'll be able to like hold the logic silent because since I've been picking up and dropping logic. So let's try and get okay. This new resolution is not, from what I can see, is not what you call it, is not normalized. Same as the mouse is not normalized. Same as the uh, it's time ever normalized. Let's get it. So on full screen is come here, add a node, call it book or GD, create. We have done this in the past before in GD script. It has to do with doing something like at on ready. Oh my god. At on ready, then we create a variable. Then we are why is my I don't know, sha. Then we assign it a name. So name is let's say color it. I will say is equal to new no. I don't know like dollar sign. What is my dollar sign? I don't know who makes a computer with inbuilt Norwegian keyboard. Okay. Then we'll use get mouse and get import. We don't need to do all that. Okay. Addressing um let's go it. Oh, oh, oh. Let's go with the champion. Ah, this place is too cold. Ah, what is the new shit I created? View resolution and view time and mouse. So here we're giving it not mouse position but mouse. And the current mouse position we're giving it. So if I should save this, then restart my editor. And to come here now, as you can see my mouse pause, even though it's a vector 2, not a vector 3. So I don't know why the arm mouse is a vector 3. What is the third parameter for the mouse? Well, that does not concern me. Let me set my resolution. Okay, color rate of the gate size. This one can be done before already. I don't want to put the bracket in the end. So I can just come in now and say color rate dot material dot set shader. Parameter. It's been long since I last watched movie. You see, U resolution. See, that's how the parts look like. Yeah, resolution. Come on, I'll be see screen. size. Why is it red? Interesting. Control V. Okay, so what's now the issue now with this code? It's not declared in the current scope. Yes, that's because it's defined on declared in the ready function control. Okay, wait. Let me create Control C, Control V, Control S. Then instead of them defining it again, we just assign the value here. Then let's reload the current project. Okay. Unfortunately, it did not do what we wanted it to do. Let's just define it here. Tacky. Hold up, they don't love you like I love you. Hold back, we don't love you like I love you. Say you. I see. Say you. I don't really wanna fight anymore. I don't really wanna argue no more. Maybe put it up and say like heaven. Come on, put a flame on me. Maybe put it like heaven. Come on, put a flame on me. I see. I don't really wanna fight anymore. I don't really wanna argue no more. Maybe put it up and say like heaven. Come on, put a flame on me. Yeah, I don't really wanna fight anymore. What was the error that I saw? Oh, this one's not. But it could be the reason why our stuff is just so sluggish. Let's clean up this folder. I just wanna be with you, yeah. I'll be fun times with the guys. I just wanna be with you. Did I spell the resolution wrong? Yes, I spelled the resolution wrong. Sharp. So now we have a wait. We're going to take time because we have time. So let's remove this time. We have time as an inbuilt function. No, I don't know. This is a minimum stuff, minimum precision. I don't think we need this. So let's go. How I long to breathe the air of heaven. Dun, 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 dun. But in the end, you see that it was worth it when he returned to wipe away our fear. There will be a day when the ages bows before him. There will be a day when there shall be no more. Standing face to face with him, world and rose again. Holy, darkest day. Da, 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 da. What was I reading just now? When he returned to wipe away fear, there will be a day when the ages pass before us. There will be a day when there shall be no more. Okay, let's just start reading from the beginning. Let me reload the page to resize. If you know be say Jesus there. If you know be say as me. No. Life. Cherry function. This chapter could be named Mr. Miyangi's fence. Previously, we mapped and normalized the position of X and Y. So, green channel. Bye. Okay, the following code structure is going to be our fence. In it, we visualize and normalize values of X and Y. st.x in two ways. One with brightness, observe the nice gradient from black to white, and the other by plotting a green line on top. In that case, the x value is assigned directly to y. Don't focus too much on the plot function. We'll go through it in more details in a moment. Okay, so So let's try and type out the sheet. And so we're using we'll create a function plot. Load. Now, let me try and type this thing with the way I was that and typing keyboard stuff that I should be typing. Let me see if I can try and gradually improve my speed. I don't know how you guys do it that you guys will hold your hand in where you are supposed to put your hand in the keyboard and yet not touch the mouse. Okay. Plot. Ah, Jesus. Plot. That's how you spell plot. But still windows. Where's still here? It is here now. So don't look at the keyboard. Oh my god. Let me switch back to English keyboards too. How do they switch back to English keyboard? No, no, I'm not switching back to English keyboard. So we have V E C 2 space S C. Come on now. Don't fuck with me. Okay, return R E C. Where's my U key? Where was U? U was above my index up. Yeah. Where's arrow? Where's arrow? Where's arrow again? Jesus, I pressed arrow just. Yeah, arrow is up. N. N is my first finger, but it's with border. Space. S. M. Enter. Okay. So now I've not reached in my lessons. I've not reached typing numbers. 0.2. 0.02. Oh my gosh. Fix your posture. Shift the computer. Developing your skills when you are coming from the baseline where I was is really difficult. People will not be able to appreciate. But like I've just been on the 36 skills level where I've been like terrible, like super terrible, but I just be deceiving myself with confidence. Okay. A I keep on fixing G. Oh my okay, B. What button is B? S. S. C. That's cool. dot y. I envy you guys that this thing came naturally to S. That's hard to see. Dots. Case X this time. Ah, Jesus Christ. I'm gonna just continue taking my one finger typing and if I was doing one finger typing, I do it slow and I'm done by now. I'll be able to do one finger typing. Oh, Jesus Christ. All right. So, that's our plot function. We're plotting a smooth step where, for the absolute value of smooth step is, let's look at a Godot definition. Smooth step. Unfortunately, you can't just do control and click here in this thing, and that's really annoying. I'm not seeing shit. The smooth step where smooth step interpolate between 0 and 1 where A is greater than C, A is less than C less than B. This is useful in cases where the threshold function desires a smooth transition. Ah, so far. This shit got me fucked up. Also, I'm just tired. Ew. Okay, so for the color, it assigned the value of UV. I'll be with the Lord. I think it's UV that I'm just also use. I don't think I'm supposed to do this long story. Wow, yeah. Giving me small color. Cause I'll be with my Savior while the ages roll on and on. While the ages roll on. While the ages roll on. I'll be with the Lord while the ages roll on. While the ages, while the ages roll on. While the ages roll on. I'll be with the Lord while the ages roll on. While the ages roll on. While the ages roll, sorry. While the ages roll on. Are we the while the ages roll on, while the ages roll on, while the ages roll on, through the valley of death, 'cause I'll be with my Savior. While the ages roll on. And the reason why my own diagonal line is facing in that direction is because in Godot, 0.0 is here, 0.0 is here at this top, and 1.0 is here, 1.0 is here. Then I think this thing is somehow like the equation of a line in a way. So basically, what they are saying is, let me see, what's the equation of a. Okay, while the ages roll on, while the ages roll on, I'll be with the Lord. I'm coming. What is root step? What's going on? Let's see whether I'm still alive. While the ages roll on, why is it good today? Normally, it's usually excellent. What's going on in Nigeria? Why is network so bad? Oh wait, is it that we are drawing a line for every value where um s dot y minus s c dot x is the subtraction is equals to 0 or 0.02? Yeah, it's going to be equaling 0 in a diagonal line. Then the smooth step function is just going to like have like a bit of space. So let's say I increase this smooth step to like 5, we'll have a thicker line because the value will be true in a bigger space. So what if I make here 0 and make here 1? I see. Inumerata Jesu. And also, if I remember correctly, the smooth step only returns 0 or 1 as a answer. Abi? Something like that. But let's finish this video, sha. This was not what I wanted, but I think him explaining what t is was able to even make me see. Because when it was like when if you plot t against t, that and get that straight line, just made it click on my head that we are doing y sty versus stx. Xty versus stx, wherever xty and stx are equal to each other and they subtract from each other, we're going to get 0. And we're plotting a plot step between 0 and 0.2, meaning that we're going to give it that space. So if it's 0 or 0.2, we're going to have that coloration because the smooth step is if what's the definition? If A is greater than or equals to B is 1, I think. So greater than or equals to this, we're plotting it. What ages roll on. And it could be less than or equals to, I'm not too sure, but that really does not matter. We'll get into that later. So let's return back here. Sorry. So that said, after we do that, so that's how we get this our line. Then we come here to this color to plot it, and we are saying 1 minus plot. So we're saying 1 minus, it's either we get 1 minus 0 or 1 minus 1, depending on what our smooth step function returns. If it's returning 0, we are saying we're multiplying the 0. If it returns 0, then this value here will be 1. So um, we multiply by color, then we add our the one value again, then we multiply by this stuff. Okay, this in y is in UVY. That's why we have the gradient. When we multiply by 1, because the plot is 0 and everything, when we multiply by 1, we just get our gradient, except from the part where we get 1 as the output from here. If we get 1 as the output from here, we do the multiplication of this. When we do this 2 multiplication, the answer is 0. So we are drawing this green line. So that's what we're doing. But personally, if I was to write this function in Godot, how I would write it is like this. Instead of doing all this long, complex mathematics, I will just come here, keep this vectory, delete all of this, create a mix function, open the brackets, put a comma here, then put the color, the second color as in UV dot and this in Y. So that's to get that gradient, okay, there's all the values of color, all the RGB values of color will be UV dot Y. So that's vec 3. I'll just have UV, or let's just use ST so that you just look normal ST. So we just give all the values of Y ST. Then we put a comma. Then we put, for the mix, we put our PCT. Then we close. What's the issue? ST dot Y. Okay, so I think if I did quite the opposite. Oh yeah, it's the opposite because smooth step, like I said before, for the value of, if a mix now, when is 1, we take the second value. So instead of doing it like this, we can either flip the order, we can say 1 minus this 0.1, I mean 1.0. So this is how I would have done it. So I wouldn't have done this 1 minus this, I'll just write this first. But basically that's what they are doing here. Why the edges long? Why the edges wrong? Now we have this function. If I remember from this guy's graph, what function actually makes that shape? Okay, so t times t is what's going to give us this curve. So basically, it's some sort of uv dot x times uv dot y to get that curve. Let's read this chart. Let's see what they are doing. Plot smooth step, ST and PCT. What's PCT? PCT is ST, comma, Y. This is making zero sense in my head. Okay. Okay. ST. ST is UV. Then comma Y. Y is is X power. We're squaring X, or we're doing X to the fifth. That's X times X to the fifth. So we're plotting. Ish. They explain what they have actually plotted. I don't know why I'm not reading. Okay, so quick observation, the vectorial type construction, you understand you want to assign three colors to the channel with the same value of vector. Understand that you want to construct a four-dimensional vector with three dimension 1 plus a fourth value of alpha. See example 19 and 25 above. The code is your friend. It is important to observe and understand this. You will come back over and over to this space between 0.1 and 1.0. You will master the art of blending shape with lines. This one-to-one relationship between x and y or brightness is called linear interpolation, and that's what we're watching here in this video. You see, linear interpolation. From here, we can use some mathematical function to shape the line. For example, we can raise x to the fifth to make a curved line. So we are raising x to the fifth power to have that curved line. Then we're plotting it against our normal y. So we bring it in st dot y. Line 22. What's happening on 22? Try different exponents. For example, let's just write the code out first. Then if I write the code out, then I will be able to simplify and convert it to a different way I can plot it in Godot too. Although I think this is, well, I can leave my mix function as it is, because okay, I can leave my mix function as it is. I come here, I create a function. Oh yeah, I just change the value of these two. How do I do exponent and power? Is it PW? Let's delete this. POW. Okay. So st dot x comma 5.0. What is wrong? Let's see what my graph is looking like. Okay, nothing has changed yet because we are not using this y value anyway, except for we're not even using the y value anyway. Before, when we use it, if I didn't edit my code, were they using the y value at all anyway? Y. No, they were not using the y value anyway before. So now we'll make y a second variable to oh yeah, they're using y. Why do they declare color like this here? Okay. It's the formulas that they are using. It's just so complicated. Wait, let me look at my gradient and compared to their gradients so that I'll know that whether my mix is actually one to one. Wait, let me cut this Control X. And let's say this st.x. I know my gradient will look slightly different, but that's because that should be only because of the variation of dark here, light here. Dark here, light here. Oh, oh, but I forgot to edit that part of the code too. Sorry. So, yeah, it's the same thing. I can just easily cheat it with this mix step so that it looks more readable. While the ages roll on, while the ages roll on, I'll be with the Lord. While the ages roll on. Okay. While the ages roll on. The ages roll on. How can I just pin this thing that regardless of whether okay let's see. So this plot is not taking two variables, comma y. Then we'll come and edit this here to take two variables too, comma floats y. What does PCT mean? Well, what we can now do is instead of plotting the absolute value of y minus this, we'll plot the absolute value of y minus 0.2 or 0.02. We just repeat it, then do the addition side. What a chic a sense do we na ni na dun 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 wa dun 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 dun. What did I do wrong? I don't think I did anything wrong, but baby, come wine for me. y is equals to uv dot x to the fifth power. Let me just put carry my calculator and see that 0 0.1 to the fifth power is a very small number. 0.9 to the fifth power is a relatively large number. Okay, so this is where when UV, okay, wait, let's look at it properly. So we are plotting, shoot this way. I want to follow where she goes. Okay, so we're plotting x raised to the power 5. So we're plotting change in x raised to the power 5. Now, from my calculation, as I've pressed my calculator, 9 raised to the power 5 is 0.59. So it makes sense that at 0.59, let's say it's 1 now. 1 raised to the power 5. 1 raised to the power of 5 is 1. So it makes sense that at x equals to 1, y will be 1. At x equals to 0.9, y will be 0.5. So y will be somewhere halfway here. Oh god, you can't see my mouse, but just know that I'm somewhere halfway here. Then, so we have this very like steep, very like slow growing curve that will just rapidly staggering. So this my graph that I plotted is correct. It's the exact explanation of what they plotted. The reason why it's different, like it's like shaped differently, is that their y is 0 in the bottom and 1 in the top. That's the only explanation to why the angle will curve like this. Now, what I need to understand that is this piece of code here. What exactly is it? Because like the line, the drawing of the line, why are we drawing the line like this? Because I have a feeling that if we use the initial line drawing method, we would have still been fine. Yeah, me open, as we're gonna do what a she done. But instead of plotting this, we can then plot destiny. So we can plot y. As you can see, it actually has this double gradient because right now what we're plotting, we're just plotting a, so like this plot function is 0. This mix is what's making it look like gradient like this. This plot function is 0, 0, 0, 0, 0, 0, 0, 0 until we get to around like 0.4 raised to power 5, where the value start looking something more like 1, then it goes up. But that's not the curved line. We want a curved line. So how are we going to plot a curved line? So we're plotting a line by saying the absolute value of this and this. So when These were, so when the value is 0, we're plotting. We're plotting, 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 plotting. We can't do that again. Instead, we have to plot when the value is between y and 0. Abi? No. That's not what we're plotting. We're plotting when y, that's the square. What is actually chipping? It makes no sense that it's chipping. Okay, it's not chipping. It's just getting so thin. It's the engine that's optimizing it to chip it like that. But basically, we're not trying to plot the intensity because technically we've already plotted the graph like this. No, so that's what are you doing? Think, Osas. Think. Why does this give you a curved line? Okay, so PCT is what? What was PCT? PCT is Y. So Y minus 0.2. Y minus 0.2. Sorry, Y minus 0.02. So how that's linear. What a shield. So, okay. And if this was plus, I think we'll have it the other way around. So now when you now isolate that sheet, you get I believe the children are the future. I understand it, but I couldn't have come up with it on my own. And that's just okay. What is basically what it is doing is saying float step. Normally step if the value is less than 0.5. If value is less than 0.5, we return 0. If the value is greater than 0.5, return 1. So at our midpoint, we start returning 1. Then after we start returning 1, what do they do with the 1 that we get? That's the 1 is now y. Put inside here, and they plot a very funny looking function. Oh, it's actually plotting the step function, like the actual step function. So like the line is green when it's 0, 0, 0, 0, 0, 0. Then at the you have this the line just automatically switches. So this thing, then this stuff here, this code here is saying this code is actually a subtraction code. Like if you remember what I was doing that time, the part that is actually lit up is not the part, or the part that's supposed to be lit up is not the part that was lit up. We're just subtracting it. So let me just plot it to you. So instead of using power, I just use step 0.5 comma uv, sorry, st dot x. What a dream. Because the way the Godot system is going to plot this way instead of plotting it's going to plot the opposite way, because their negative is our positive and our positive their negative. If we want our own system to plot the way their system looks like, how will I flip the axis now? We can come here and say st dot y is equal to 1 minus st dot y. That wouldn't flip it, that would just shift it. They flipped it. Make it make sense. Wait, let me. So now, where is 0 becomes 1, and where is 1 becomes 0? Yeah, like because 1 minus 1 is 0, and 0 minus 1 is 1. Okay, so now we look like them. It's me and my twin, go best friend. And now if we plot in that power again, we should now get the right looking power. Power st dot x comma 5.0. It's me and my twin, go best friend. We're killing it, no friend. Get rid of him. All this no day. Then this curved one. This was what was that function I gave the curved graph again? I think it was smooth step that no, it was not smooth step that did that. This guy's voice sounds familiar. I've watched another of his video tutorial, right? Okay, smooth step that plots that shit. Says a smooth step. Get rid of them. All this no do do. I ain't feeling it. It's just me and my twin. Go best friend. Got feeling like a whole new friend. It's me and my twin. It's me and get rid of him. All this no do do. I ain't feeling it. It's just me and my twin. Go best friend. Got feeling like a whole new friend. In the previous example on line 12, notice we have been using smooth step to draw the green line on the plot function. For each position along the x-axis, this function makes a bump at a particular value of y. How? How? By connecting two smooth steps together, take a look at the following function. Replace it for, think of it as a vertical cut. The background does look like the background. Why can't I not read? Take a look at the following function. Replace it for line 20 above. That's this line here. Okay, let's replace it. It's just me and my twin. Go best friend. We're killing it. No friend. Get rid of it. I'm feeling it. Yeah, I noticed it that these lines will get fatter at a point in the line. Take a look at the following function. Replace it for line 20 above. Think of the vertical cut. Think of it as a vertical cut. The background does look like a line. The background does look like a line, right? Sine, cosine, y equals to sine theta will give you these plots. We can actually just do that actually. What is it? Let's see. Ugo nakana. Let's see st.x. Oh, sorry. Uploading a line. Let's multiply it, maybe multiply by 3. So we have not still shown the full bracket. What's pi? Multiply by pi. So we have the full graph now. Kuchua kolo jump away. Try the following exercise. Add youth sign to before x before computing this sign. Yeah, we can also do this now. We cannot just multiply this by time. That's disgusting. Was it add that I should add time to it? Wait, why don't I add time? I know that I'm to add time, but I don't think I should add time inside the same function. No, it will only show on the screen once if I do that. So that's not the solution. Wait, why don't I just add a very little of time plus time times 0.2. It's not repeating. Why is it not repeating? Oh yeah, we need to keep it inbound. So we need to multiply by 0.5, then add 0.5. So long we get high, so long we smoke weed. We just having fun. We don't care who sees. So long we get high. Okay, the value of time is too small that we're adding. Let's make it 5 or slightly faster. So long we just having fun. Let's make the wave a little bit. Let's multiply pi by 2 because why not? At least I can see 2 waves in the screen at the exact same time. So long we get high, so long we just having fun. We don't care who see. Sharp. So let's see what other thing can we do. Multiply by pi before computing the same way. Oh, this is what I was even doing. Frequency, U time, add 1.0 to sign to see how the wave displays. Hopefully you don't know this exercise. Some extra function. At the end of the last exercise, I will introduce some new function. Oh, add the higher integer cell, add the smaller integer flow. exact sign, absolute. I know how to use all these stuff. Look like the trace of a bouncing ball. Oh yeah, it's true. I actually can, instead of um doing this behavior, this long code. How come they don't call any error for me having to stuff there? I can actually just do this absolute value of sign. So if it's negative or positive, it doesn't matter. A, B, S. But who typed in just now? Oh, sorry, it was a sign. It was different. Okay, well, the magnitude is actually different. Just now I was scaling it so that I could fit, but right now it's just doing this thing. What I did was that I actually just, when I multiply by 0.5, I will reduce the graph size. When I add 0.5, when I add 0.5 to it to increase it to be in the positive side, what it fundamentally does is that it increases the whole thing. So these sharp curves actually is not going to be there because like we're just adding it. I don't know how to explain it. Even myself, I believe it, but I do not understand. Basically, we're adding to the whole thing. We are losing the shape because it's not the same shape again. So it's a scaled down shape. We are like halfway. We have halfway lost the shape. All right. Saw wave. Saw wave. How would I be able to plot this log saw wave? Wait. So if I just plot x, that's not going to give me. Okay. Oh wait. No, no, no. I can get a saw wave by. Mod st dot x comma 0.5. So 0.5 divided by 0.5 is 0. So there's no remainder. So the mod operation will not plot anything. Same thing as 0.5. Then start again with start again, remainder start increasing until it reaches there. Now how am I going to shift it? Instead of giving it the value of st dot x, if I give it the value of sign, I give it the value of st dot x multiplied by um, multiplied by pi. and is the absolute value. Not quite there yet. No, absolute value is not going to do the right thing. Instead, let's use our normal scaling. We multiply by 0.5 and we add 0.5. Why the fuck is the line curving? Oh yeah, the sine wave is not straight, it's curved. What is sine pair? So the sine is a value from 0 to 1, but the value is not straight, it's curved. So how do we make it straight? Well, we never really needed pi actually. In fact, we never needed pi. We never needed the sine wave for the value. We needed the sine wave to move the value. So it's just sine time we need. Sine time. Then we're going to add. Yes, we're going to do addition. Add. I'm going to do uv dot x. Yeah, I'm moving the saw wave. But if the ability to be oscillating, we're not going to do the absolute value. So that it moves in only one direction. Absolute value. Something. But if you see this, we're still oscillating, even though we're just technically oscillating in one direction. Are we oscillating in one direction? We're not oscillating in one direction, we're oscillating in two directions. The reason why is that we're not actually increasing the value of UV dots. This thing. Dot X. I don't think we need a sine wave to make this thing move. This is one of the rare cases where just adding time will move it. Because you see, yeah, just adding time will move it. Because we are doing the mode of 0.5. So 0.5 is going to return a remainder until you reach the next 0.5 spot, then the next 0.5 spot, then the next 0.5 spot. So I didn't need to go through all that stress. When we have our moving saw wave. Advanced shaping function. It has a great documentation of complex shaping function that are extraordinarily helpful. Porting them to GLS is a smart way to move to building your own resources of snippets of code, polynomial, exponential shaping, circular, elliptical, busy and other parametric function. Money. But we've done this once. Okay, no, we haven't done it. It's a different one. So we're plotting with impulse. What the fuck is impulse? Impulse is k times x, then the exponential of h. That's what's already concerned me. I got like hella money. Take a look at the following tables of equation by this. See how you combine the function and their property to control the value of 0.0 and 1.0. Now it's time for you to practice by replicating this function. Remember, the more you practice, the better your character will be. Wow. Wait. What the fuck is it? For your toolbox, that have a computable function which can easily be included to your version. Cuckoo, 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 cuckoo. Celebrate the night. Come on. Let's celebrate. Celebrate tonight. Come on. Celebrate. Dun, 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 dun. So you can be the one. We haven't had much chance to talk about GLSL vector type. Before going further, it's important we learn about the we know how to do this one as well. Okay, what is this? This classic red, yellow, green, blue, red. Okay, we're starting with red, we're ending with red. How the heck is it added in it? Okay. All these overly complicated codes. Makeup is my friend, makeup and I just be that strong. If I listen, if I listen, I feel come, come inside, come, come. Ding, ding. Like what you saying? I can't even read this code. Like it's as bad as I can't read this code. What kind of poorly written code is this? Or is it that I'm just dumb? What is c.pg? What's k.xy? Like when did we define k? Okay, look at k is defined here. Where did we define c? Oh, see where we define c here. Okay, we take in an input vector HSB to RGB. HSB to RGB. Because you first loved me, that's the reason we. Okay, that means you're not using this one at all. I'm blessed in the morning. Let me just import this to Godot so I can look at it in Godot side. Blessed in the evening, Abraham's blessings are mine. You him sing Abraham's blessings are mine. Hallelujah. Abraham's blessings are mine. I'm blessed in the morning, blessed in the evening. Abraham's blessings are mine. Shake a friend and tell me if you love my Jesus. Shake a friend and tell me if you love my Lord. I want to know, I want to know if you love my Lord. Happy to be you, happy to share one another's burdens. That's why we turn around and shake somebody. That's why we turn around and shake somebody. That's why we happy to be here. Happy to share one another's bodies. That's why we are here. Mm, mm. So we are taking in the value of for our red value of RGB. So for our red and our green value, Of as a we're taking in as c dot x. C dot x is our uv dot x, and c dot z is our uv dot z, and c dot yeah, z is our uv dot y. Then what we're now doing is that we're clamping the value to be the absolute value of the mod of c dot x, that's our uv dot x, times 6. So we're scaling uv dot x to 6. Then we're adding a vector. Jesus Christ is Lord. Why the fuck are we doing this? So this is a value. This value now is going to be ranging from 0 to 6. While this one is going to be ranging from 0 to 10. And this one is going to be ranging from 0 to 8. And we're going to be dividing it by 6. If you divide 6 by 6, you get 1. If you divide 10 by 6, you get 1 remainder. One remainder 2. Sorry, 1 remainder 1. Then you divide 8, you get 1 remainder 1. So you are actually now, for the mod, your mod value can be anywhere between 6 divided by the mod value can be because before you get to that exact 6 on the dot, this one too is going to be returning a mod of values less than 6. Same thing on this ones. On this one. When you get those values at, wait, you minus it by 3. Why are we doing all this? We first do the mod before we minus. After we get the mod, then we get the absolute value. Wait. This absolute value bracket, how far does it go? Since when the absolute value start taking in comma? This makes absolutely zero sense in my head. Okay, no. We're dividing by 6 to get the remainder. Then we're getting the value of 3 minus the remainder. And the remainder minus 3. Then we're clamping the value. Wait, remainder minus 3, we're getting the absolute value of that. Then we're minusing 1 from it again. Which kind of mass is this? Let me give it to ChatGPT because it makes absolutely no sense. Or maybe I'll just watch a video on HSB RGB. Control Z. This is a classic high optimized snippet of converting HSB, hue, saturation, brightness, or HSV to RGB in GLSL polarity by Inigo queries. Instead of using heavy if or else statements, for the six different color sector of the hue wheel. It uses periodic math function, mod, absolute, and clamp. The GPU are incredible fast at executing. Here is a step-by-step breakdown of the math wizardry at work. Generate a hue rainbow RGB equation. Why the fuck would this generate a rainbow? Somebody should explain to me. Yeah, I've taken that. I'll have to stop now. I'll have to stop soon. Ctrl C, Ctrl A, Ctrl V. Bro, you talk too much. I just want to know. I don't know what I want to know. I just want to know why that stupid mouse work like that. Why have I been watching my stream? I've just been wasting my data. You know what? I think it's a very big leap. Why don't we draw a rainbow without using this HSB stuff? I cannot sit down to figure it out because um my laptop is off, so I don't have that time. Create a function that draws this rainbow in normal one comma one. Sing hallelujah to our God, glory hallelujah. In one accord, every prayer. I did not say do HSB to this thing. I said draw a rainbow. What's the CX value? I would have copied this, but I'm not going to do that nonsense. Since the pressure is already on, I don't want the system to go off on its own, so I'm going to just shut it down. Save and quit. I might come online later in the day.